everybody. Uh, in this topology right here, in this video, what we're going to be doing is that we're gonna take this topology and we're going to manipulate. Now, since we have a basic understanding of how spanning tree protocol will impact our network, then we want to go over the process of investigating and confirming, also manipulating the spanning tree algorithm. Okay, so we have here the switches on this top part of the topology, S2 and S3, uh, connected with a redundant link. Now, there is not, just as in the previous video, there is no Ethernet happening here, and this is a flat layer 2 topology, simplified for purposes of demonstration. So what we want to get out of this video is to see how uh, we can manipulate spanning tree. So by looking at this, we can see that each switch has a priority value that is the same. So all switches have the same priority value. So as we mentioned before, if that's the case, then spanning tree will then go and take uh, the MAC address to break the tie. Now, and again, in spanning tree, lower is best. So, since all priority values are the same, then spanning tree will uh, take into consideration and choose the switch with the lowest MAC address. And for the purpose of seeing that, we know that by looking at this, the MAC or the lowest MAC address, all of these MAC addresses begin with 00, and then the next two digits are 02 for S3, switch 3, 60 for switch 1, and then E0. Now, we know that uh, this switch 3 has the lowest MAC address. Okay, so because the first two digits are the same on all switches, then the third value or third digit, the lowest among all, is the one for switch 3, which is 0. So by looking at this information, we can tell that switch 3 should be the root. Now, if we want to confirm that, we can go to the command line, right? And then we can investigate. And we can take a look at that by typing the command. So first enable and show spanning tree. All right, and yes, as we predicted, this switch is the root. Okay, so there are two different pieces of information right here. Okay, we have information about the root. Okay, and this information is about this specific device. So as you can see, the first piece of information, the first block, is talking about spanning tree, and it's actually working the oldest spanning tree. We didn't went into too much detail on that because knowledge of these theories are assumed, but we can change this and we will as well. So it's talking about spanning tree. It mentions that the root ID priority is as follows, it's this one, and the MAC address is this one right here, right? So since this is the bridge, okay, is going to be the same down here, because this piece of information is talking about our device, and this is the general spanning tree information for the entire topology, basically the root, okay, information. So we can confirm that. So we are in switch 3. Let's open up switch 2, and let's take a look at what I mean in order to take a look at the information. Enable. First enable. Now show spanning 3. And okay, so as we see here, we can confirm that this information about the root, okay, and as you can see, it has a cost of 4, and the port is 1 gigabit Ethernet 1/0/1. Okay, and so that is the information for switch 3 right here. Okay, it's telling us that we gathered this information from that switch, which is connected to our port, to the port gigabit 1/0/1. Okay, now our information down here is as follows. So this is our MAC address. Okay, so this is our MAC address. All right, so our device and the root information. Okay, all right. So by looking at this, let's see what happens. We know that this switch is the root. So if this is the root, then we must have the following situation. First and foremost, all ports should be designated ports, because that's the reward it gets for being the root. All ports will be designated ports. Okay, and since we need to figure out after that the root ports, so first let's confirm about that, and there you go. So all interfaces are designated ports. Okay, so we got that correct. All right, so moving on to switch 2. Switch 2 is not the root, okay, but it must have a few things going when it comes to spanning tree, and we talked about in the previous video. Basically, switch 2 have to have a designated port, okay, and a root port. Now the root port, in order to connect to the root, we know that it's directly attached, but it has 2 different connections, and in this case, gigabit 1/0/1 happens to be the lowest ID. So we didn't talk about this much in the previous video, but again, let me just go over it. So we have 2 different paths. Both have the same cost of 4, because we're dealing with gigabit interfaces. So it has the same cost. So it's going to default to choose what? The lower bridge ID. Now the bridge ID, since is just itself, right? The bridge ID, then is going to choose the lower interface value. So in this case, it's going to choose gigabit 1/0/1 as its root port, and then the other one is going to be on the designated port. or blocking port rather, because it must have a blocking mechanism uh, to break the loop in this section, right? So gigabit 1/01 should be the port or the root port, and gigabit 1/02 should be on blocking mode. So let's confirm that. Now, what about this one right here? Gigabit 1/03. What about that? Okay, so first to make sure about that we had the correct information, let's deal with switch 1. So the root port for switch 1 should be gigabit slash 0/2. Okay, and the other one here, between these two, we need to figure out which one's gonna be the designated port. Now again, designated port, which one's gonna be? We both have a direct connection to the port, to the root bridge. Okay, but my uh, my priority are the same. So if priority are the same, then what about the MAC address? So again, switch 1 will be the designated port. So switch 1 gigabit 0/2 should be the root, and gigabit 0/1 should be designated port. So let me just mark that. Okay, so down here, the root port. Okay, and this designated port. All right, let me just block. Okay, and block. Okay, and then this one should be designated. Now let's see if we have that correct. We said that this one should be designated, this one should be blocking, and this one also should be blocking. Now let's see if that's correct. Alright, and then all of it on this side should be designated, and we already confirmed that. So how about our theory with the rest of the switches? So on switch 1, this interface gigabit 0/2 should be a root port. Now let's see if we have that correct. Go to the CLI, enable, show spanning tree. Okay, so let's see if we were correct here. We mentioned that gigabit, okay, so gigabit 0/2 should be the root port. And do we have that correct? Gigabit 0/2 is the root port, and we had that correct. And we said that the gigabit 0/1 should have been the designated port, and we had that correct. All right, so we have this prediction down here, up here correct, and we have this prediction correct. Now what about S2? We said that gigabit 1/01 should be designated, and then the rest should be blocking. All right, so there you go. As we predicted, the gigabit 10/1 was supposed to be the root port, right? And everything else should be the blocking state. So 102 blocking, and 103 blocking. And that's exactly what we have. Now I said designated, but it's actually the root port because it's connected to the root. Okay, so that was correct. Now how about if we want to make a change here? I want switch 2 to be the root. How can we do that to manipulate our STP or spanning tree algorithm? Okay, so the way we do that, okay, we go to switch number 2, okay, and we go to configure terminal, and we're gonna do the following: spanning tree mode, and I want to be rapid per VLAN spanning tree. Okay, so if we take a look here, we were running the old spanning tree version, and the convergence for this is long, so it's gonna take less time to converge if something happens if we use rapid per VLAN spanning tree. So let's see if we can do that. Rapid spanning tree. Okay, perfect. Now, if we want to make this root or this switch to act as the root, then we are going to provide the following command. So spanning tree, okay, VLAN 1, because we're running only one VLAN in the entire network or topology. Okay, and we're going to have two options: priority or root. Now we can go ahead and say, yeah, I want to be the root, but we also can go and make a priority, okay, based on number values. So here we have from 0 all the way to 61,440, but each increment have to happen in this amount, in 4,096 increments. So we can go either way. We can go or put the lowest value or lowest legal incrementation, which is 4,096, or we can go to the lowest, which is 0. And I like this better because I have even more control over my devices and what exactly I want to accomplish. So I'm going to go, because I want this specific switch to be the root, and I'm going to add a priority of 0. I'm going to hit enter on that, and that will trigger spanning tree to make a change, and this root and this switch should become the root. Now, what about I want S2 to be the next in line, right? So I do the same thing. So I'm gonna go here, okay, spanning tree mode, rapid spanning tree, okay, and spanning tree VLAN 1, and let's see, priority, and 4,096. All right, and then I'm gonna make this switch to also participate in rapid spanning tree. So show spanning tree. I'm still running on the old version of spanning tree. So let's change that. Okay, and spanning tree, VLAN 1. Okay, so I'm gonna leave this alone. I'm not gonna make any changes in that. So how about now do show spanning tree. Okay, now we see that we're no longer using the old spanning tree protocol IEEE. Instead, we're using the more efficient spanning tree protocol, rapid spanning tree. Now, what about over here? So, let's see if we have indeed become the root. So I'm gonna go over here. I'm gonna paste that command there, and that should be the root. And hold and behold, I am the root. Okay, I have a priority of 1. How about the one that used to be the root? Where we at? Oh, now I have a priority of 1, but guess what? I am not the root. Okay, priority because of the VLAN. But look at this, spanning tree enable, rapid spanning tree. Okay, and now my port has changed because I'm no longer the root. Now I have the same thing that I had before on S2. So, and now uh, blocking on 2 interfaces and forwarding, having this interface acting as the root port. Alright, and there you go, folks. That is how you manipulate your spanning tree. Now let's see if I can show link legs. Alright, so there you go. So this is what we have right here. And hopefully this has been a helpful illustration, and this is all for spanning tree. I'll see you in the next video.